Let's talk about solving radical inequalities. So we're going to be using a number line here. We've used the number line before, and it's a number line that keeps coming back again and again, so you'll get more comfortable with it as we do it with different types of functions. So I'm going to go ahead and draw a number line. Now, the first thing I'm going to do when I have a radical is to find the domain of all the radicals. So basically, I'm going to find the values that x can be based on the radical. So remember, square roots. In order to give us something that is real, the thing under the square root has to be greater than or equal to 0. So I'm going to say 4x plus 1 is greater than or equal to 0. Remember, if it's negative, it would give us an imaginary number. So if I solve that for x, that tells me that x is greater than or equal to negative 1/4. Those are the possibilities just for the radical. So on my number line, I'm going to put negative 1/4, and I immediately know that anything less than that, because it's not in the domain, is not going to work in the inequality. So we won't even have to check anything with that. So then what I'm going to do is I'm going to solve this as if it were an equation. So I'm going to write this exact same thing, but with an equals sign. So I'm going to solve it by reverse PEMDAS. So subtract 3 first, divide by 2, square both sides, subtract 1, and divide by 4. That number also goes on the number line. Now, we have numbers that basically are between negative 1/4 and 2, and numbers that are bigger than 2. And on the number line, these two different intervals could either work in the inequality or not work. So what I'm going to do is pick numbers. So I'm going to test, sort of like a test point. I'm going to pick a number between negative 1/4 and 2. So I'm going to pick 0. So I'm going to plug that in to see if it works. So let's see, I believe that gives me 3 plus 2 times the square root of 1, so that's the square root, which is 1. So 2 times 1 is 2, so that says that 5 is greater than 9. Nope, that's not true. So that means because 0 doesn't work, none of the numbers in the interval with 0 work. So now I'm going to test a number bigger than 2, and I look at this and I say, how about, I don't know, 3? If I test 3, and you can use a calculator with this, this gives you the square root of 13, which is somewhere between 3 and 4. You can obviously get the decimal for that. So when I double it, that would give me something between 6 and 8. When you add 3 to that, that's something between 9 and 11. So that's definitely going to work. So that means these answers work. So I know where on my number line the answer works. So I'm now going to write the answer, and that is this spot right here. So that would be x is an element of 2 to infinity. Now, when you have two inequalities, the process is, sorry, not two inequalities, two radicals in the inequality, the process is still the same. I'm going to draw a number line. I'm going to do my domain first, but this time I have two radicals. So x plus 8 has to be greater than or equal to 0, and x plus 3 has to be greater than or equal to 0. So that says that x has to be greater than or equal to negative 8, and x has to be greater than or equal to negative 3. So if I put negative 8 and negative 3 on my number line, negative 8, anything less than that, not going to work. Negative 3, anything less than that, not going to work. So now I can focus on solving this equation. And if you remember, we isolate a radical, we square both sides, but on the right-hand side, when we square it, we'll have to FOIL that out. And when you FOIL that out, you're going to get 1 plus 2 times the square root of x plus 3 plus x plus 3. And then I work to isolate that radical. So 1 and 3 make 4. I'm going to subtract 4 and x from both sides. Divide both sides by 2. Square both sides. Subtract 3 from both sides. Put that on my number line. Pick a number between -3 and 1. I think 0 works just fine. So I'm testing 0. Square root of 8 minus the square root of 3. And again, you can use the calculator for this. The square root of 8 is like 2.7-ish. The square root of 3 is like 1.7-ish. Actually, I think the square root of 8 is 2.8-ish. Yeah, when I do that subtraction, I get like 1.09 something, which is not less than 1. So if I plug in something bigger than that, let's say 3, that would be the square root of 11 minus the square root of 6, and I want to know if that's less than 1. And when I do that in my calculator, I get 0.867, and that is indeed less than 1. So my answer is this stuff, which is x is an element of 1 to infinity. So keep in mind when you do test these intervals, the things you ruled out from the domain, like these things back here and this, those will never be the answer because they don't give you anything real. But when you look at, when you're testing your intervals, either of these could come out as the solution. It just so happened that both of them were the one on the far right.